The question we are going to solve today is LeetCode 460 LFU Cache. It is one of the hard level LeetCode problems and all-time favorite for Amazon, Meta, and Google in their interviews in last 1 month. So what does this question say and why is it a hard level problem? So this question is very similar to an LRU cache, which is least recently used cache. So if you have not done that question before, I would suggest you do that question as well. Now let's see what does this question say. So you have to design and implement a data structure or a cache for LFU. And in this class, you will have two functions. One is a get function, other is a put function. In get function, you basically give the key and you get the value. Input function, you basically insert a new value corresponding to a key. But what happens if the cache is already full and there is no space available to put that new value? In such a scenario, you have to first pop some value. And which value will you pop? You will pop least frequently used value. But the complication arises if you have more than one values which have equal count and both are least frequently used. In such a scenario, you cannot pick up any one of them randomly. You have to pick up and pop the one which is least recently used, as indicated in the question here. So to determine this, which one is the least frequently used or which one is the least recently used, you have to use a counter and you have to maintain that count. Now, the statements and the requirements of the question were not that complex enough, but there is one more complexity. You have to code this get and put function with O1 average time complexity, that is constant time complexity. Besides taking care of the count, besides taking care of the least frequently used value, besides taking care of least recently used values and handling all the edge cases, you have to do everything in O1 time complexity. So that's how the complexity of the question increases. So let's look at one of the examples here. So you have been given an input, LFU cache, put, these operations have been given to you and the count gets updated. So just as indication, I need to tell you, whenever you are inserting the value for the very first time, the count gets initialized by 1. So whenever you do the put operation for the first time, the count gets set as 1. But when you insert a new value for the same key which is already there, then the count increments. The count also will increment when you perform a get operation because it is being used, right? So that's the catch here, and that's how the count is changing. So I hope you understand that. And every time the output is given to you. For example, use of counter for the key X here, whatever key you are inputting. And cache is the cache you are maintaining. And least frequently used cache is your data structure where you are recording all these outputs. So first thing is LFU dot put 1 1. So you have to put key value as 1 and value is 1. So you have to do that. So it inserts key 1 and the count for 1 gets updated to 1. Now is LFU dot put 2 2. So again, count 2 would be 1, count 1 would be 1. LFU dot get 1. So in that case, 1 value is 1, it returns 1. So earlier the return value would be null because there is no get operation. Here the return value would be 1. Now the next thing is LFU dot put 3 3. So since count of 2 is 1, but you have already been provided that your LFU cache capacity is 2. So that's why LFU dot put 3 3. 2 is the LFU key because the count of 2 is 1. It's the least frequently used key because count of 2 is 1, whereas count of 1 is 2 because you performed a get operation there and a put operation there. And hence, count of 2 is 1, so it is the smallest and we invalidate 2. First of all, we pop 2 and then we insert. And count of 3 is 1 and count of 1 is 2. Now LFU dot get 2 is the next operation, but 2 you already popped, so it is not there. So return this -1 not found. Now next operation is LFU dot get. Now get 3, you have to return the count of 3 would be 2 because there is a get operation also happening here, and you return the value for 3 and count of 1 would be 2. Now the next thing is LFU dot put 4, 4. Now, as you can see, both count for 3 and 1 is 2. So least frequently used would be either of the two. But you cannot pick one randomly. You have to pick one which was least recently used. Now recently you did a get operation of 3. So the one value with 3 is recently used. So you have to pop 1. And then you insert 4. So now finally your count 4 would be 1 and count 3 would be 2. Now then if you dot get 1, since 1 has already been popped, there would be no 1 finally found there and you return -1. Now and if you dot get 3, you return the value for 3, but at the same time you will update the count of 3 used would be 3 because there's another operation that happened with it, and count 4 would be 1. Now and if you dot get 4, return the value for 4, but at the same time the count 4 gets updated to 2 and count 3 gets updated to 3. That's how this question works. Now I hope the question is clear to you, but how do we solve it? So to solve it, we'll be using a doubly linked list. Now the complexity here is that we do not have just one doubly linked list which we can use to track key value pairs, but we have to have more than one doubly linked list to also track count versus the linked list related to that count. So say suppose there are certain key values such as 1, 2, 3, which have counts as 1. So you will have all of them in a doubly linked list mapped to a key value of count 1. Similarly, you have another doubly linked list with a key value of count 2. And that ways you will have n counts and you will have n doubly linked list mapped to it. And whenever you have to pop a value, you check which one has the minimum count, which one has been very least frequently used, and you check for that linked list. And when you have to pop something out of that linked list, this is the least used value, this is the most used value. So you will have to pop this value, and that's how you need to pop every time. And once you pop this value which has count 1 and is least frequently used, then you pop this one, then you pop this one, and so on. And once you have exhausted the entire linked list with that particular count, you start popping from the next one. So you have to keep a record of the least frequently used value currently as well, because you have to update that. So I hope you understand that now. I know the question is complex. If you have any doubts, ask them in the comments here. Now let's look at how do we solve this question. So first of all, I will have a list node class. That's how I will call any list node, right, in my linked list. So I will write that class value. This is an init method there. And I will initialize my value there and 2 pointers, previous and next pointers there. As simple as that. Whenever you initialize a linked list, you create a list node class, and that's how you do it, right? So now you write a doubly linked list class. I'm not going to explain each and every step we do in that, but I'm going to explain the methods I have created in that linked list class. There are several ways to create a doubly linked list, and you can use my method. There could be a more concise approach. You can look for other approaches as well. So I'll explain my approach. So I created an init method and I initialized 2 dummy nodes, one left node, one right node. For right node, I provided the previous as self.left. And then I mentioned self.left.next is self.right. That's how I initialized 2 dummy nodes and established their connections. And I also initialized the self.map with a dictionary. And what will it have? It will have key value pairs, right? That's how you keep a track of them, and that's how you access them in O of 1 type complexity. So then I also have a length method to return the length of that map. And I have a push right method because push right would be used push some value or to insert some value whenever a put method is called. And then I have a pop method. This pop method is used to take out some value in between from the linked list anywhere it is available, it could be in middle of the linked list. And then pop left method is actually popping the least frequently used one. So getting the least frequently used one. So that's how you do pop left. And so basically the one which is least frequently used is this one. So you pop this. So pop left method does that. And update is a combination of pop and push right. So basically you pop a value in between the linked list somewhere, and then you push it towards the right side. So that's the entire doubly linked list coded here. You can create it any which way you like it, and you have done it before, or you find an interesting way to do it. You can do that. This is my approach. So I'm just skimming through it and letting you know. So after that, the main part of the code, the crux of the codes, because you might get the doubly linked list coded from the beginning itself, so that you don't have to code from the scratch, but you have to code this from the beginning. So let me explain this code. So this is my init method where I've initialized certain variables. So I have to keep a track of what capacity has been provided for the LFU cache. So self.cap equal to capacity defines that. I also have to initialize least frequently used count. And when I'm starting with the cache, I don't have it. So I initialize it with 0 right now. Then self.val map where key value pairs are mapped into the dictionary. So I initialize it that. And then self.count map would be collections.defaultInt. And then you will have a self.list map, which will be collections.default linked list. So basically here, collections.defaultDict, you map key and count pairs, and list map, you map count and linked list pairs. So that's how you are creating two linked lists, okay? After that, I write a method called counter. This counter method would be basically my method which I call whenever I want to increase the count. So say suppose the get method is called. You have to increase the count in that scenario for that key, right? And say suppose put method is called. In that case also you have to call this function to increase the count. So I have generalized this method, and how my writing is define counter self key. And first of all, I call that keys count. So self.count map key, because count map has count versus key pairs. So I call that and I save that count, okay? Now whenever this counter method is called, that means get or put operation is happening and you have to increment this count. So I increment that. Self.count map key incremented by 1. Now my job does not end there. I have a list map where the linked list which was earlier connected with prior count, it needs to be popped from that linked list and needs to be pushed to the other linked list with the increased count. So that's what I've done here. Self.listMap count, which was the prior count, I pop the key from there. And then I push right that key to the count plus 1 list. So that's how you do it. And then I have to handle another edge case where I have exhausted and popped all the nodes from count 1. So I have to move to count 2, right? So that's what this edge case is handling. If the count is equal to self dot least frequently used count, that is my prior count when entering this counter was self dot least frequently used count, and I don't have anyone which has least frequently used count now. So self dot list map count dot length is equal to 0. That is, I've exhausted the entire linked list of that particular count. Then I have to update my least frequently used count by 1. So that's what I have done. Simple. Your least frequently used count was, say, suppose 2 earlier when you entered this loop. And you have exhausted all the list nodes which had count as 2. So you have to increment your least frequently used count as well, right? So that's what you're doing it here. That's my entire counter function. Now my next method is get. In get method, I first check if the key I'm trying to fetch is there in my value map key value pair or not. If it is not there, I return -1. Now, as I indicated, whether I'm calling get method or put method, I have to increment the count. So I call my counter function here for this key. And finally, I return my self.value map key. So I have to return that value for the key, right? That is shown in value map dictionary. So I just return it from there. Now my put method. This is a little complex. It has a lot of edge cases, so let's understand it better. Now my put method, I first will check in the question I have been provided with 0 capacity. If I have been provided with 0 capacity, I cannot do much. I have to just return. So I'll do that. If self.cap is equal to 0, just return. Now my next case would be when my key is not there in self.value map, that is my key value pair has not occurred before, but my capacity has been reached. So my length of self.value map is self.cap. That is, my capacity has reached, but I have not inserted the new key which I have to insert. So in such a scenario, I will do pop left. I will pop the least frequently used one. So that's what I'm doing here. Self.list map, self.least frequently used count dot pop left. So I'll first get least frequently used count 1. Then I get key corresponding to that list map. I get the linked list, linked list corresponding to that count. And then I pop left from that. So I'll store that value in result. And I have to pop that value from both key value pair dictionary and count key pair dictionary. That's what I've done here. And finally, whenever you do put operation, you have to call counter on key because you have to increase the count for that key, right? That's what I've done here. And you have to insert that value to key value pair. So self.value map equal to value. That's how you insert. And finally, you have to update your least frequently used count. So it might just be the case that the value you are inserting might have the least frequently used count. So you have to take a minimum of the current self dot least frequently used count, the current one, and the value you are inserting that count. So self dot count back the key. So if the value you are inserting that count is minimum and less than the current least frequently used count, you have to update your least frequently used count. So that's your entire code. I'll just run it. It's accepted. Let's submit. So as you can see, my solution is doing really well here. The time complexity is O of 1 because we are doing all of O of 1 operations. Since you have created a map here, that's why your calling also is O of 1. But your space complexity would be O of n because you're using hash maps here. So I hope you understand. I know the question is complex and suggest you pause the video and try this question once more. Try coding it yourself. Try coding your W linked list yourself. And let me know if you have doubts in the comments here. I'll be happy to address it. If you like my way of solving questions, subscribe to my channel to get your notifications for your daily LeetCode challenge. Thank you.